Sandy MUNRO is going to be here to tell us what really happened at Tesla's Battery Day, give us his impression and also some perspective of what to expect moving forward. My interview with him is coming up next. Welcome to E4 Electric, your #1 source of electric car scoop. And I know a lot of you are still very excited. Some are a little disappointed and some are simply confused. I think I am a little bit of all three, but what better person to have here to talk about the Battery Day, what really happened, than Sandy MUNRO. Now, Sandy and I have covered quite a few topics. As a matter of fact, the second part of our conversation was mainly dedicated to the $25,000 Tesla and how the Model S Plaid mode essentially is going to be a test vehicle for this new technology to implement it to the rest of the Tesla fleet. And we also talked about why can't Tesla have the $25,000 car now with the current technology. So I've decided to take that part and spin it off into another video, which I will publish next week. So only more reasons to subscribe to this channel if you haven't already. So click on that subscribe button and the bell notification icon so you don't miss anything moving forward. Now, speaking of an affordable electric car, before we get to the interview, I gotta mention that this video and this channel is sponsored by KANDI AMERICA. Have you met the most affordable electric car in America, K27, for just under $10,000, including the federal tax credit, or their second model, K23, for just under $20,000? The deliveries start just in 3 months, so hurry up and reserve yours using the link in the description of this video. And by Evanex, the Tesla community's accessory store. Use E4 Electric, the name of this channel, as a discount code for all of your purchases over $100. All right, Sandy, so we just had the Battery Day. A lot of information, but I think most of us, and some people are disappointed, some are excited, but most of us need some therapy. So why don't you? Yeah, that's where you come in. Oh, really? And tell us, what are the things, just in general, from the sort of a bird's eye view, what are the things that you saw that excited you, and were there any things that you were also disappointed in?
Actually, I was not disappointed in anything I saw. I'm a pretty happy guy. As you may or may not know, during my videos, the ones on MUNRO Live, I made a lot of predictions as to what would be coming out shortly. And all those predictions came true and then some. I've got to tell you flat out, I was really happy to watch what I was watching on Battery Day yesterday. It was phenomenal. To me, I was so high I couldn't believe it. I was interviewed 3 times right after that show, different magazines. Some you'd know, like Bloomberg, others they wouldn't mean anything to you because they're trade magazines. But I will tell you that I am a very excited guy after watching what was going on. I predicted that there was going to be a new battery, and that was going to be, it was going to be 50 by 70, and he surprised me, and he changed the dimensions to what, 80, yeah, 46 by 80. It's the same volume, but it's a little different. And he also surprised me with the tab construction. We've heard about that before. We've heard people try it before. It didn't work. He did it. Kudos to him. And I was shocked at, I predicted a while ago that, you know, he should get rid of the what do you call it there, the 107 or whatever parts there were in the wheel inner, and he came back with a casting that was much bigger than we were expecting, and it's a single piece. And now it's a single piece, and now what he's talking about is doing the whole front end. And he's going to shoot the, he's going to have a battery case that's going to be structural. And I said that it would be a good idea to start thinking about that in 2018, and here he is, he's got it. And he's putting these batteries in. So the 2170, like this one, okay, that's a nice battery. I like it, it's the best there is, but I did not like the way it wicked away heat. It didn't do a good job at that. I wasn't happy with the amount of work it took to glue this thing into position. But this one, this is the right way to go. This is about the right dimensions, and we're actually setting up a battery case with this to find out how many batteries it's going to need. Our customers really would like to know what's going on, but this is going to be a tremendous improvement with range, power, and especially weight. This is going to take about 50% of the weight out of the battery pack. That's big stuff. And all the other yo-hos that I read about on, I don't know where these clowns come from, but I read about all of the stuff that these characters are saying that, you know, well, this isn't really what we were expecting. Well, what were you expecting? What were you expecting? Were you expecting that he was going to pull a rabbit right out of his butt and say, here, look at this? No, no. He came up with something that everybody is interested in. This battery is super duper. I'm really happy. And this right here says I don't even need the what do you call it? Solid state? No, the solid state fuel. Sorry, the solid state battery. I don't need it if I've got this. This will take its place. This is good enough to get me going. And certainly now, I made a prediction, I think, last time we talked, and I said the ice age is going to end in 2030. Two things have happened. This, and California is saying today that, that no more gas cars after 3035. I bet you they change that and move it down shortly.
So tell me a little bit about what are you holding there? Is that a prototype? Is it something that actually you got from Tesla?
Oh, this is a mock-up. This is a mock-up. This is just something for us to just put into. We're gonna make what we think the battery case is going to look like, and from looking at this and what they told us on the show, and what our own calculations on what the density is going to be, then we know that we'll know how many of those batteries are going to be needed per car. We're going to be able to know what the range is. He said 500. That sounds good to me. But I want to check. You know, I believe everything, but I want to validate it. Our customers want to see for real what's going on independently. So yeah, I'm super duper geeked. I really like what's going on. He did a great job.
So now those characters you were talking about earlier who expected a lot. I'm one of them. I'm one of them, but mainly because I feel like Elon hyped me up for a miracle, and I was expecting it. What I was expecting is a 1,000-mile on one charge battery, and so explain to me why, you know, because, you know, we're talking about a 50% improvement in range in about 3 years, which, you know, an average Joe like me cannot be excited about that much, right? I thought maybe we can come up with an electric car that goes further than any gas car. So explain to me why even this 50% range over the 3-year period is a big deal.
It's a big deal because it basically eradicates the ICE engine. People aren't grasping this. I mean, think about it. What did I say about the Tesla Model 3 only 2 years ago? I said that it was one of the worst cars I'd ever seen as far as being put together. I said I didn't like a whole bunch of things. I'm not going to get into it, waste time. But what did he do in 2 years? He pushed out the Model Y. I keep telling everybody, Elon Musk lies. And he always understates what he's going to do. I'm telling you what, take everything he says, cut it in half. He's going to be out with us in 1.5 years. He's only doing that so he can get the other guys in the fight to think that maybe they have a chance. I mean, again, where's that book? Oh, Tyler, can you give me that thing? Give me that book there. The Art of War. Here's a ticket, boys. All those guys in Wall Street, they got MBAs. I got this book right here. This is how you win. And that's what he's doing as well. Understate. understate to your competitors or your enemy. And that's what he does. He understates. And then all of a sudden, oh, what happened? Oh, you said, oh, I didn't know. Oh. That's what you want. You want him terrified. And that's what he's doing. I'm telling you, everything he said. Here's the other one. He talked about, not to get off the battery topic, but this is the magic right here. Hopefully you can see that. That's the magic little chip that's going to make the ADAS system work. Now look at the back as far as connectors. Who's got that? Okay, NVIDIA. Everybody used NVIDIA, right? He doesn't use them anymore, right? He's going to change the world, and it's going to happen so fast that the dullards that are sitting behind thinking, oh, we've got plenty of time to catch. No, you're not. No, you don't have enough time at all. I'm telling you what, I'm geeked more than I've been in I don't know how long. And he doesn't even pay me. I mean, I'll tell you one thing. We're not going to talk about Nobi on this, but I'm going to tell you right now, I'm going to buy all my parts, all the parts I possibly can from Tesla. I want stuff that I know is going to be able to be around and serviced. I want Tesla parts in the cars that I design.
All right. Yeah. Well, so let me ask you this then, because you're talking about competitors. I mean, recently Lucid Air prototype was able to achieve confirmed independently an EPA estimate of 517 miles, and they're using the, obviously the regular LG Chem batteries. They claim that Peter Rollison, the former, chief engineer of the Model S, he essentially explained that they've achieved that with essentially making everything else around the batteries much more efficient. The motors, the cooling system, the drag efficient and stuff like that. So, do you think that, first of all, what do you think about that, them being able to achieve that without the breakthrough tech, battery tech that Tesla just unveiled? But also, does it also mean that Tesla can take a page from Lucid's sort of manual there and make some improvements in their efficiency in other parts?
Maybe. How many vehicles has Lucid got on the road?
Well, just as many as Tesla has the new batteries in the plaid mode, right? I mean, this is
in other words, zero. Okay, so here's the thing. I put my money on those who actually made something, sold something, and put it into the marketplace, right? That's my big thing. I like to see that, and I don't see that with anybody else. So when I look at this, and I see what this potential is, and like I said, I predicted that we're going to have to go to something that's going to be about 2 inches in diameter, and it could be 80 millimeters long. In this case, it is. But I'm telling you what, this is what I want to see. This is the battery I want to see. Okay, LG Chem. LG Chem is our buddies. We've used their batteries on lots of different programs. We've analyzed them. We've costed them. I've talked to their people. I know their chemistry. I know everything about them. But to get 500 miles, I need a bigger battery pace. I need to put a bigger battery box in. That means more weight. More weight. The two biggest things against electric vehicles is weight and friction. Weight and friction are your two biggest enemies. So I look at, I don't know what their motors look like, but I do know what Teslas look like, and their motors are superior to everybody else's. The weight is less, the cooling is better. I'm pretty happy with what their motors are. I haven't seen the Lucid motor. Are they making it themselves? I don't know.
They're making everything in-house, and they're claiming that their motors are the best in the market because of what you mentioned.
But they're not in the market.
Right.
Once they're in the market, I'll buy one of their cars, I'll tear it all apart, and I'll be able to tell you for real. No guessing, no nothing. I've got everybody's motor now, and I'm waiting. Like I think we're going to be getting a Porsche Taycan powertrain system. I believe it's coming to us, and when I have that, then I'll pretty much have a good handle on pretty much everything that's in the marketplace. And then I'll be able to compare all those. There's 12 engine. We have a 12 engine study that we're selling. to everybody in China, well, not everybody in China, but a lot of people in China, most of the people in Japan, and most of the people in Korea. In Europe is even buying them. But the U.S. is not. And I have no idea why. Do they think that they've got something better? If they do, how do they compare it? How do they compare it? You're going to buy a car and tear it apart yourself? It's $1 million. Why should you waste your time and money? The Chinese aren't doing it. The Japanese aren't doing it. The Koreans aren't doing it. And even some of the European companies aren't doing it. But here we got this arrogant thing. I want to see what it is. I want to be able to put numbers against it. How much did it cost? How much did it weigh? What's its friction coefficient? Well, all these different things that happen when I want to see how good something was.
All right. So let's go back to Tesla. And obviously you mentioned, the weight reduction, and, one of the breakthrough technologies they've talked about is essentially getting rid of the battery pack per se, right? So they're going to build that into the structure of the car.
Right.
Can you talk a little bit about it? Because I have some questions. Obviously, people right away brought up, the safety, whether or not, the battery is, it's flammable, apparently. And secondly, how would the cooling system work without a battery pack kind of going through and stuff like that?
Okay, so when we tore apart the Model 3, if you remember, I criticized the body because it was too structural. The body was the same had the same structural integrity as the battery pack, and everybody has been using the battery pack for structural integrity. So you become redundant, and that doesn't do anything for you but add weight. Now, the Tesla fans all yelled and screamed at me, pointed at me, and said, we're going to, I don't know, come down.
Oh, come on, Sandy. Tesla fans never do that. They never scream or yell. Get out of here. That is one thing I just don't accept here.
At the FBI guys down here. Anyways, at the end of the day, we said what we said. So the Tesla fans were very unhappy with me saying that. They said, we need that for safety. And I said, no, you don't. It's redundancy. If I drive a tank, am I safe, or did I just a little bit over design it? Now Tesla did what I said they should do. I said, hey, you know what? Why don't you build the battery pack so it's part of the structure? And it is. The only difference is their battery pack is taking these and putting them right next to each other, and then filling it up with what do you call it? Epoxy. You know what? That becomes one great big gigantic brick. And there is no way in hell somebody's going to tell me, oh, it's somehow going to get punctured. Bull. A lot of things might happen in a tremendous crash. I think if you hit it with a train, it would still survive. Maybe the wheels would fall off and the people inside would definitely have a bad afternoon. But I think that the battery pack would just bounce off and go into the ditch. And that's a fact. That's why I'm really impressed. I am so impressed with the way they're putting their battery pack together. How's it going to be cooled? Okay, so if my hand is the lower plate, and I can't bend my hand that way because I broke my wrist, but anyway, let's say that this is the lower plate, and that's got the coolant going through it. Boom. The one thing I criticized, the main thing I criticized on this was, why are you cooling the sides? That's not where the heat is. The heat runs axially. It runs out of these two surfaces. It doesn't come out this way. Now he's got it. He's going to go clunk like that. He's going to fill the sides up with epoxy. And you know what? I believe that when he puts the top plate on, he's going to try and suck heat out of that as well. Perfect.
That's so brilliant.
And you're saying even with the tabless batteries, the heat would still be at each end rather than also around the body?
Absolutely. And actually, it's even better. It's even better with the way the tabless battery has been around for eons. Lots of people have tried it. Nobody's been successful. He's going to be successful. He's already got them built. He's already testing them. So with the tabless, what's going to happen is the aluminum is going to be low and the copper is going to be high, and he's going to fold over. Now he's going to have to do some funny manufacturing. So the tab is going to start out, or sorry, the the filaments are going to start out wide, and then they're going to have to get narrow, because as I'm wrapping these things together, the inside ones are going to be, they're going to wind up being bigger than the outside ones. So we have to make it so that at one end it's square, because let's say it's the copper side. The one end has to be square, and that'll be so that it can interface with the gap the copper side, and then the other side it'll degrade slightly so that you can wrap them, and then you still wind up at the top with a flush surface. So he showed that. I don't know how many engineers they got in New York, but I'm telling you that is brilliant engineering, and I'm telling you that that's going to be a great way to wick away the heat, because it's got a bigger surface. I just absolutely love it. Everything I saw, I'm excited about, but that means that I'll never get a job as an analyst. It doesn't matter. I don't care.
All right. Now, let's. Now, you mentioned that batteries will not be whatever. We're not even calling it a battery pack, but the battery module.
Well, it is a body. It's a big, giant battery pack, but there are no batteries. There's only cells. These are not called batteries. They're called cells. So there's only cells and a battery pack. That's it. And you get rid of all the other crap. And like I said, all those things, looking at it, you couldn't get it apart anyways. It's all welded shut. This is absolutely brilliant. I'm very happy. And remember, I said something on your show before. I said you can have serviceability or reliability, but you can't have both. And what he did was he picked reliability. That battery will last a gazillion years. Your grandchildren can use it to run LEDs, or maybe your Starship. Who knows? I don't know.
All right. Well, first of all, I need to get children first before I get grandchildren. I've heard.
Oh, we have people that can help you with that.
All right. Okay. We should talk about it after the show. Yeah. Wow. I didn't know I was gonna. I thought we were talking about batteries, not matchmaking. But all right, that's fine.
Oh, it's hard to say.
We're making chemistry either way. I get it. All right. So now there's something that Elon did not talk about yesterday, so maybe you can kind of fill in here, because obviously the charge rate of the battery is important, because one of the biggest issues with electric cars right now, you can't fill them up as quickly as you would a gas car, not even close. And the problem right now with Teslas not being able to, let's say, get to 350 kilowatt maximum charge rate is because they have a 400 volt system, and other cars like Taycan and going with the 800, Lucid's going with 900 volt system. They're doing that. Now, obviously, the problem is not in just in voltage; it's also in amperage. Will these batteries be able to keep the 400 volt system, but be able to take higher amperage, and therefore Tesla will be able to achieve 3, 4, maybe 500 kilowatt charge rate?
Okay, so here's what everybody is kind of forgetting. When you plug in, 80% of the battery gets charged up really quick, and you can take off and go wherever you want. You don't have to have a full battery in order to make yourself feel comfortable. 80% is good enough. So I am going to hearken back to the olden days, okay, when I was younger than I am now, for sure. So I remember, not my dad, because we didn't have a car, we were too poor. But anyway, and my dad only had one eye. So I can remember driving with Mr. Beauchamp, and he had us all in his truck. And he would drive up to the pump. And in the olden days, people used to put gas in your car. I mean, whoo, what a concept. Anyway, he'd drive up and he'd say, "Eric, give me $2." That's all he needed. That's all he needed for now. In the olden days, people used to think that, hey, well, that gas is in the gas tank. It might be evaporating. I'm not going to put much in. And that was the paradigm that they had. What electric drivers want is, I need that topped up completely. No, you don't. If you're in a hurry, pull in, spend 5 minutes, whatever, 10 minutes, top it up and go. I mean, you don't have to wait a half an hour to fill the thing up entirely. It'll tell you when you need to go and find another charging station. And most people, they don't don't need to charge it up all the way. It's just, it isn't necessary. Don't bother. So that's one thing. The second thing is, okay, 400 volts, that's a big deal. When you get to 800 volts, now I've got a lightning, I mean, that's lightning in a bottle. And I know that they're going to be able to solve that. I mean, there's going to be all kinds of clever things that they're going to have to do in order to take the charger and plug it in. But 900, 800 volts, that's a lot of volts. So now let's talk about the other aspect. Let's say we all go to 800 volts and we're all plugged in at the same time. What happens when the windmills start going backwards? I mean, what happens when Niagara Falls starts going back? I don't know how much capacity the United States is going to have when we start moving into 800 volts. But I will tell you one thing. That is definitely, I mean, we could wind up with a brownout in New York if everybody was charging at 800 volts. And that's one of the other things that the Europeans are rubbing their chins on. It's great if you can do it, and it'll be great for that guy. But it might be a little bit of an issue for the grid and other things that are sitting out there. I don't think we have to worry too much about that.
But do you think that these batteries will be able to achieve a higher charging rate without going to the higher voltage?
I'm pretty certain that, okay, so I drive to work every day, and in a week I might drive 500 miles in a week. I don't drive 100 miles a day. It's just not. And most people don't. So what do I need that for, really? I mean, I thought 150 miles for a charge was good enough. And a lot of smaller vehicles, that's precisely what they're going to do. They're going to stay at 150 miles and say, good enough for me. 500 miles. How many times do you travel across the United States? How many times are you going to go and visit grandma 2,000 miles away? It doesn't happen very often. And when you do, if you're driving 500 solid miles, you're definitely going to need to use the restroom. I guarantee it. And the kids might need a snack, and you're probably going to want to look at something else other than the road. So I believe that there's good potential that the 400 is fine. Now, the guys that are looking at 48 volts and stuff like that, I'm not a big fan. I think that 400 is a real good number, and that's kind of like what I think we should be focusing our attentions on.
All right, for the second part of this conversation, mainly dedicated to the $25,000 Tesla, don't forget to subscribe to this channel, and I will publish that video next week. Before you go, Sandy is actually looking for some investors for one of his upcoming projects. I can't tell you what it is, so contact him at leandesign.com. I put that link in the description of this video. And if you want to know what's going on outside of the Tesla's universe, check out my video about the Volkswagen ID.4, which was unveiled earlier this week, which essentially will be a competitor to the Tesla Model Y. I actually got to check out that car in person, so the link should be up there, but I also put it in the description of this video. All right, looking forward to all of your comments. Other than that, see you guys next time, and remember to stay charged.